Hello everyone. I, I hope I'm audible. If not, please let me know. And so, welcome to the problem solving session for NPTEL course Getting Started with Competitive Programming. This is week 4, and today we are going to thanks. So, today we are going to solve some practice problem for week 4 content. And so, if you have gone through the content already, you must know that week 4 topic is disjoint set union, and so we will be solving today a problem related to that. And so I have already shared the link to the problem in the chat window with you. I hope you were able to access it. Now I will be sharing my screen and so that you can see the problem. Yeah, I hope my screen is visible to you. And so like every other week, today we follow the same thing. We first look at the problem statement, then we will solve a couple of examples. After that, we will try to solve the approach. We will try to solve the problem, we'll discuss the approaches and the time complexity. So yeah, thanks Aryan for sharing the link. Everybody, okay, I hope you can see it on my screen as well now. So the problem, I will just read the problem statement, or so what do you prefer? Do you want me to read, or you just want me to display the problem statement? And I think that is better. I'll just display it and let you read through it. And yeah, I'll give you some time. Let me know if when you want me to scroll down. Okay. I'm scrolling down. So these are the constraints, and this is an example. So, like always, I'll request you to grab pen and paper and also work out the examples. Okay, so I hope I hope you all got a chance to read the problem. So now we will just discuss that. So the problem says that you are given n submissions, okay, and these n submissions are owned by n people, and they are saying that ith submission belongs to the ith participant initially, okay, and every submission is given a score initially, which actually never changes, okay, and then there so that is actually your input, and after that you are given q queries, and there are two types of queries. One is the 0xy, which says that for submission x and submission y, they will compete with each other. I mean, the owners of submission x and submission y, they will compete with each other, and whoever has the submission with the highest score will win, and all of the submissions from the loser will then move to the owner. Basically, the loser will be eliminated from the game, okay. So that is this first query. It also says that if the two submissions belong to the same owner, then print that it is an invalid query. And if they do not belong to the same owner, and if the owners both have the same maximum score, then it is a tie, and in that case you do not do anything, okay. And if one of them is a clear winner having a score greater than the other, then in that case the submissions from the loser will move to the other, that is the winner, and but you do not need to output anything for this query, okay, except for invalid query, this print statement, when it is an invalid query. And for the second query, which is you're given x, where x is the submission id, and you need to output the owner of the submission, Okay, output the index of the participant who owns the submission X at that point. So in the input you are given integer t, which denotes the number of test cases, integer n denoting the number of participants in the contest. Then there are n space separated integers where ith integer represents the SI, score of the ith element. Then you are given q, where q is the number of queries, and the q lines follow, where each line is of the format either 0xy or 1x as described in the problem statement. And for each test, print in each line the answer for the queries as described in the problem statement. Now the constraints are, there are maximum 25 test cases, maximum value of participants is 10 to power 4, maximum value of the score is 10 to power 6, maximum queries are 10 to power 4, and x and y belongs like less than equal to n. Okay, then this is the example here. Now I'll just wait for you guys to work this out for 1 minute, and then after that we'll discuss this. So is the problem statement clear? If so, you can open the problem in your tab also, in your browser, if you want to reread it. Can you guys tell me if it is clear or not? If it is not clear, then let's go over it again. So this is the example 1 which is given. Okay, we are given that number of test cases 1, n is 2 participants or 2 submission, okay, which are equal, and the score of each submission is given in this array S, where submission 1 has score 1, submission 2 has score 2. Then there are q queries, which is 2. First query is of type 0, which is 1, 2, which says that submission 1, the owner of submission 1 competes with owner of submission 2. Okay, and then you do what is suggested in the query. Okay, and then after that the second query is of type 1, which asks that who is the owner of submission 1. Did you get the output 2? This one? And if you okay, every others, let's just work it out. It's very easy, but let's see. Okay, so here query 1 is this. Okay, it says owner of 1. Who is the owner of 1? So currently submission ID and owner ID are initially same as given in the problem, as is already given in the problem statement. They are initially same. So submission ID 1, owner is 1, submission ID 2, owner is 2, right? So owner of 1 is 1 and owner of 2 is 2, right? They will compete with each other, and for that, I mean, the score of So a owner can act generally, it can have many uh, submissions, but it will always use the submission with the maximum value, maximum score whenever it is competing, right? Because that is the best strategy. So here we can just say that the score of owner 1 is 1 here, and for 2 is 2. So clearly owner 2 is the winner here, and therefore owner ID here will change for submission 1, right? Since they are, I've kept this in both in the, sorry, this won't change, this is the score, sorry, that won't change. Okay, so next is query number 2 is asking who is the owner of submission 1, so which we can see from the here that it is true. Now let's look at some other example. Example 2, which I want you to work out. So t is equal to 1, n is equal to say 5, s is equal to say 2, 5, 4, 3, 7. Okay, and then you are given queries. So first query is 0, 1 and 5, 0, 2, 4, 0, 1, 3, 0, 2, 5, and so on. We can add more queries as we go. So let's try to work this out. So anybody having any doubts? And after that, let me just write here the queries of type 2, which are going to which I will ask for every submission, that who is the owner. Okay, so for query 1, so for solving query 1, here we, let's say here we have submission ID and owner ID. Let's first create this mapping here. Okay, so initially we know that it is their same. Right, and then there is then this is this, then there is owner, let's not take this for now, and then after that, so first query is 0, 1, 5. So who is the owner for 1? So owner for 1 is 1, 5 is 5, and then we are going to compare 1 with 5. So then the score for 1, I mean submission ID 1 is 2, and the score for submission ID 5 is 7. So owner 5 is the winner, and therefore ownership of the submission 1 will go to 5. So this will be changed. Second query is 2, 4. So in this we can see that the score for 2 is 5, score for 4 is 3 here, right, which is given here. So then owner 2 is the winner, and therefore the owner for submission ID 4 here will be changed to 2, right. Next is query 3, which is 1, 3. So submission ID 1 owner 5, submission ID 3 is owner 3, and so 5 owner has 2 elements now. One is 1, I mean submissions, not elements, and submission I may use interchangeably. So 1 5 has two submissions, 1 and 5. The score for 1 is 2, score for 5 is 7. So it will use 5. And the owner 3 has only one submission, which is submission 3, and the score for submission 3 is 4. So 5 is the winner. So here the ownership will go to 5. Next query is 2, 5. Okay, so 2 and 5. So owner for 2 is 2 and owner for 5 is 5, and 5 has the greatest score element, which is 7, so it will definitely win. And then both of the elements which are belonging to 2 will go to 5. So ownership will change at both these places, here and here, both these places. Okay, so now at the end of all the queries which we had, all the submissions belong to owner 5. So all of these queries from here, they will all return 5. So the output should be 5, 5, 5, 5 and 5 for this particular example that we just did. Sub ID, owner ID 1 3 2 5 3 3 4 2 5 5. How did you get that submission ID belongs to owner? Other IDs. Okay. Okay, yeah. Third query, sure, I will explain it again from the beginning. So I'm saying that we have here n participants, okay, and every participant has one item or submission, and it's every submission I'm saying has an ID. Okay, ID, why do we need to give an ID? So that we can uniquely identify all the submissions, and the queries also use the submission ID. Okay, I hope that is clear. So there are two, and every owner, which is the participant, is also having an ID because they are unique and we want to. Initially in the question it says right here that you will be given n submissions, okay, to the contest numbered from 1 to n, with the ith submission belonging to the ith participant initially, right? So when I created this mapping here, initially I gave that submission ID 1 belongs to owner 1, submission ID 2 belongs to owner 2, 3 to 3, 4 to 4, 4, 5 to 5, because that is what we are given in the problem statement. It's not given in your test cases. It's already given in the problem statement. Now what is given in your test case is, it says that you are given the scores for each submission. So the submission 1 has scored 2, submission 2 scored 5, 3, submission 3 has scored 4, submission 4 has scored 3, submission 5 has scored 7. So you are given scores of each the submission in this array. Okay, now it is just you just need to compete the owners with each other. Okay, so you are given a query of type 0. Type 0 query is what? That you need to conduct a competition between the owners of these submissions. So you will be given two submission IDs, like here 1 and 5. So that means submission ID 1 and submission ID 5 here. So first since you need to do the competition between the owners, so you need to find the owner. Who is the owner? So you will look at this mapping which you have. Okay, here you know that owner for 1 is 1, owner for 5 is 5. After you know that, now you need to find that which is the maximum valued submission owned by this owner, because a owner can have more than one submissions. Initially it has only one submission, but later when it competes with other owner, it will acquire the submissions from the other participants. So now owner 1 has submission 1 whose score is 2. Owner 5 here has only one submission which is 5 with score 7. So who has the maximum scored submission? That is 5. So 5 wins. Whenever someone wins, that owner will get the submission of the other participant. That means we change the owner ID here to 5. And that is how we did the first query. Do you have any doubt in what I just told now? Then I will move to the second, third and fourth queries. Okay, great. So now let's look at the second query. The second query, now let me just initialize this so that I can just do the changes and also show. So this was initially like this. We have already done query number 1, so this is 5. Now let's do the query number 2. So query number 2 is submission 2. Submission 2 owner is 2. Submission 4 owner is 4. So remember, what you are given in the query is the submission ID, but you need to compete the owners with each other. Okay. So when you get here the owner is 2, you get here owner is 4. Now since right now they have only one submission with each other, so you just compare the score of these two submission, like submission 2 with submission 4. So 2 score is 4, 4's score is 3, so 5 is greater than 3, so that means 2 will be the winner and submission 4 will also then be transferred to 2. That is our like after the second query, this is how it will look. Then we do the third query. Third query is that submission ID 1 and the submission ID 3, you have to compete the owners of these two. So owner for 1 is 5, owner for 3 is 3. Winner between 5 and 3, that we need to find. So 5, so then we need to find the score of 5. What is the score of 5? So 5 now has two elements, this submission ID 1 and 5. So maximum of we can just say, so maximum of score of, I'm really sorry, I will confuse you, I think. Let me just say it in words only, that score of 5 is the maximum submission value it has. So it has two submissions, one with score 2 and the another submission is 5 with score 7. So we can just here write some maximum of 2,7, which is 7. This is the score, or we can say the value for owner 5. And score for owner 3, it has only one submission, which is 3, which is 4. So winner is the one with the maximum score, with the greater score. So winner here is 5. Okay, so that means we will move the submissions from 3 to 5. So now the owner for 3, submission number 3 will become 5. I hope I just gonna rub this. Is this clear? The query number 3. Okay. Now let's do query number 4. So 4 is 2, 5. So here submission ID 2, owner 2, submission ID 5, owner 5. So 2 has currently, so owner of submission ID 2 is 2, owner of submission ID 5 is 5, and 2 has, like I can just write owner 2 has submissions 2, 4, and owner 5 has submissions 1, 3 and 5. Now the maximum score between submission 2 and 4, so 2 has 4, 5 and 4 has 3, so we get here maximum 5 and we get here maximum 7. So the winner is 5, and all of the submissions from 2 will move to 5. So that means the ownership is moved. So this becomes 5. So that is the problem actually. Okay, so after that you can have, like in middle also you can have these one type query which is asking, like, which given here a value x, this is value x, which is the submission ID, and you need to return who is the owner of the submission ID. So then if you are asked all of these query in the beginning before any zero type queries, then here you would have returned 1, 2, 3, 4 and 5. But after, if you do all of these queries and then if you run, then you should get 5, 5, 5, 5. All of the submissions now belong to 5. How the owner 2 has submission 2, 4. So owner 2 got 2 submissions when, one second, I'm just going to rub this extra part. Okay, so when did owner 2 get 2 submissions? So it happened when we ran the query number 2. So query number 2 is that submission ID 2 whose owner initially was 2. Okay, owner of submission ID 2 is 2, owner of submission ID 4 is 4, right? Now we compare the submissions of owner 2 with 4, which is actually here nothing but the same submission, because currently they have only one submission each. So 2 has only one submission, which is submission ID 2, and 4 owner has only one submission, which is submission ID 4, and the scores for both are, like for 2 it is 5, for 4 it is 3. So that means the participant 2 is the winner, because the participant 2 has a submission whose value is more than the value of the other participant. So here 2 wins, and when 2 wins, then we move the submissions from the loser to the winner, and the loser is eliminated from the competition. So then submission 4 will be moved to submission 4 will be moved to the participant 2. So it will have then 2, 4. Like I'm just saying that participant 2 has now submissions 2, and 4 after query 2. Is this clear? So the problem statement is just a bit confusing because the submission ID and participant ID are initially same, and then it becomes a little confusing. But I hope now the problem is clear. So if the problem statement is now clear, then you think about that how you are going to solve this problem now efficiently. What I did in front of you by keeping this mapping was not an efficient or not even a solution. So now since it is a problem belonging to the topic disjoint set unions, so that is a hint actually that you can solve it with disjoint set unions. So then how will you solve this? Explain owner 5. Okay. Exactly when? I mean, query, can you tell me the query number? Is it visible? Is it not visible to anyone? Okay. Okay, those who are not able to view the screen, could you please check? And okay, so you're asking 135. Does that mean I need to explain the query number 1, 3 and no? Which step? There is no fifth query. Query number 4. Okay. Query number 4 was 2, 5. So after doing the first 3 queries, to owner, so participant, let me just say here that this is a participant 2, and these are the submissions which are owned by these participants. So participant 2 owns submission 4, 2 and 4, and 5 owns 1, 3 and 5. This is what we have after doing the first 3 queries. Now in the fourth query, we are going to compare these two participants with each other. Okay, and participant 2 has submissions 2, 4, submission, okay, and submission 2, so let me just write here like this, submission ID and score, okay, which is also there actually, but just writing here again, 25437. This is your input, this is given to you, right? S, this is the array S. So submission 2 has score 5, submission 4 has score 3. So the maximum score of participant 2 is 5. Okay, it's 5. And for 5 the maximum score is 2, like max of 2, 4 and 7, which is 7. Now if you compare these two values 5 and 7 with each other, you'll know that 5, that on participant 5 is the winner because it has a submission with higher score. So then the submissions from participant 2 will move to this. So after this query, this will look like this, that the participant and submissions, if I write, sorry for the bad handwriting, so it has null and 5 has all the submissions. It already had 1, 3, 5, 2 and 4 will also move to it, and all the others which are not written here like 1, 3, 4, they also have no submissions. Query 4, query 2. Is it clear now, or you want me to explain again these queries which you just written? Each time check the parent of both the submissions, parent score. Each time check the parent of both the submissions, parents score, and make the winner parent of loser, and both the elements are owned by the same person, then print invalid. Yeah, Abir, I think I'm just I was sorry I took a little pause because I was trying to understand. Yeah, you are right. I think you were talking in terms of disjoint set union operations only when you are saying making parent, right? Yeah. So you are going to check the parent of both the submissions, right? Then if both the parents are same, then that's an invalid query. But if both the parents are different, then you are going to check the parent score. And if the score, then you find the winner and you make the winner the parent of the loser. Yeah, so that is exactly what is the solution. Yeah, that's correct. And okay, so Shashank asked me to explain, I think, query 3 also. So like, I'll just quickly explain that and then we'll discuss the solution. Let me just wrap this all. Okay. So initially, let me write P for participant, S for submissions. I write SUB so that there is no confusion. And initially, this is the mapping that we have. Okay. Then after query 1, 5 will be the winner because 5 has submission with score 7 and 1 has submission with score 2. So 5 is the winner. So submissions from participant 1 will move to 5. So after this will be null and this will move here. Then second query is 2, 4. So submission 2 belongs to submission, this is the participant actually. So summation 2 belongs to participant 4 and summation 4 belongs to participant 4. Sorry, summation 2 belongs to 2 and 4 belongs to 4. And after that we are going to compare 2's score with 4. So 2's score is actually 5 and 4's score is 3. Right, from here 5 is greater than 3, so that means 4 is winner, so 2 is winner. So when 2 is winner, then this summation will move here. So after doing all of this will move here. Then query number 3 is 1 comma 3. So 1 and 3, where is 1? Summation 1 is here. Where is summation 3? It's here. So we are going to, so these are there. Then what is the score for 5? Score for 5 is 7, because the highest value submission for fifth participant 5 is 5, submission 5 with score 7. 3 has only one submission, which is 3, and the score for that submission is 4. Here 7 is greater than 4, so 5 is the winner, and this summation will also move here. So after doing this will move here, this will not be here anymore. And one more query, which is 2 comma 5. So when we do 2 comma 5, then we are going to, so 2 is here, 5 is here. Again the same, owners are 2 and 5. 2 has maximum value submission is which? 2 with score 5. Sorry, here I'll write the score 5, and it has 7, so 5 is the winner. So all of these will move here, right? So these are going to move here. That's how this will happen. I hope it is clear now. And since there is less time available now, we should discuss the way we can solve this problem. So what we are going to solve this with disjoint set unions. So we are going to have so every submission we will have all of these submissions. Initially every submission is in a different set. Okay, 1 2 3 4, they are all different sets. And submission 1 is owned by 1, 2 is owned by 2, 3 is owned by 3, 4 is owned by 4, and 5 is owned by 5, like that. Okay, and so if you are familiar with the disjoint set union data structure and all of that, then you know that we maintain a parent array. So how do we represent this initial sets? Here is, we have this array where these are, so these are the parents. This is the parent and this is our submission ID. Okay, so submission ID is parent is 1, 2, 2, 3, 4 and 5. Okay, now when we do the query of types, if we have a query of type 1, then we just return this, we are going to do a find operation. Okay, and if you are also familiar with the find, so find is like this, find v. So where we do, if v is equal to parent of v, then return v, else find parent of v, right? So this is the find operation. So you will, whenever there is a query of type 1, you are going to run the find operation and find the parent. If there is a query of type 0, then you first need to find the parent of 1, parent of x, then the parent of y. Then you are going to get these parents. You are going to find their scores from this array S, and whoever is the winner, if they are different, considering they both are different owners, they're not the same. If they are same, if the submission belong to the same owner, it's an invalid query. If they belong to different owners, then it is a valid query. In that case, if the scores are same, then you do not do anything. If the scores are different, then you are going to change the parent. The winner, you are going to, so it will be like this here. If owner, sorry, I'm writing down here. If owner of x, where x is the submission ID, is not equal to owner of y, okay, and so after this, then you are going to do that if s of x is greater than s of y, then you are going to make parent of y is equal to x, right? Else you will make parent of x is equal to y. So this will be the logic in your union, and this is usually what the find operation is. So there is a small change in the logic of the union, and doing this, we are going to have this update this parent array. Is this clear? Okay, I hope I scroll down, and then now yeah, I hope this is clear, because whenever we are going to have these whenever we are going to find the owner, so who is the owner? For owner also we are going to do the find operation, right? So owner is actually find here. Because find is going to return us the owner, so it's nothing, no different function here. It is the find. So we are going to use the find to find the owner, and once we have, if the owners are different, then we are going to check the score for that owner. So okay, so this is actually a little different here. So you just use here, you write here find winner, and because find of x will return some some owner, and this is also going to return some owner, and then you are going to find the winner among them by comparing those values. And similarly this will change. So maybe I should write here that if this W is the winner, if it returns the winner, and let's say assuming, the pseudo code will just change a bit here. Find of x will return some ID. So you need to find the score for that, and then compare the score here, and let's say W is the winner, and I'm just going to remove this thing here, okay, and just write in plain English for now. Let's say W is winner and L is loser. Then you are going to do here parent of L is equal to W. Yeah, so earlier when I had written S of X and S of Y, that was not correct, because X and Y are initial summations that you are given. You will not be comparing S of X with S of Y. You're going to find the owners for the submissions, and then you're going to compare the score of those owners, right? So I'm just writing here in just plain English, that if once you do this, then find the owner, then after that you find who is the winner among those owners. If W is the winner, L is the loser, then you just update that the parent of L is W. Okay, so this is how you're going to do the modify the union operation and the find. And here find, here union is only order of 1 time. No, sorry, union is not order of 1, because there is a find operation here, which can take order n times, right? So order n time that we can reduce by doing path compression. I'm sure you have already read this in the algorithms class, or maybe in the video in the lectures. So then you are going to update. So in path compression we modify this here else statement, and it just modifies to here. Sorry, there is return also. Right, so this is path compression. So after doing this, this modification is called path compression on the find operation. And when you do path compression, the intuition is that when you are finding the parent of one element, so example, like if this is how the ownership is, let's say I will just use the array like this. Let's say initially this is how the ownership is. So this means 5 here in this with this parent array, you will have this hierarchy like this. That owner of 1 is 2, owner of 2 is 3, owner of 3 is 4, and 4's owner is 5. Okay, sorry, here. Now with path compression, what you are going to do is, let's say there is a find operation for 1, that find the parent for 1. So parent for 1, we are going to start looking. So when we look for parent of 1, then first is 2, okay, then we go to 2, so 2's parent is 3. So that it terminates when the v is equal to parent of v, like v is parent of itself, then the find operation terminates, right? So when it terminates at 5, then recursion will return 5. Then we are going to assign that to here. So like when it returns 5 on 5, it returns here 5, and then after that 4 will also return 5 here, so it will be updated, it will be updated here, it will be updated here. So all of these will get updated. So next time if you have to find, let's say for 2, if you run find of 2, so you will find that parent of 2 is 5, then you will go to 5, and then you will find the parent, because 5 is parent of 5. So now you need to make only one lookup. Earlier you would have need to make, or in worst case, order of n lookups in this array. So that is the path compression algorithm, like what we say, optimization. So I'm just explaining this because if you do not do path compression here, then the find operation will take order n time, and our problem time constraints are given such that here that if so n is given 10 to power 4, so order n will become 10 to power 4, and if each query takes order n time, then there are 10 to power 4 queries, which means 10 to power 4 times 10 to power 4, which is 10 to power 8, and then there are 25 test cases, so it will be roughly like 10 to power 9 operations, which usually is not good. Like you will probably get time limit exceed error, so it should be about less than 10 to power 8 operations. So if you apply the optimization path compression, then the complexity will become t times q times log n, okay, which will be about 10 to power, which will be less than 10 to power 6, I think. No, which is actually 10 to power 6. Okay, how the parent becomes 5. Okay, I think you're asking about the compression technique here. So if you're not so I'll explain this here. So this is your initial parent array, right? I'm hope you can assume that this could be your parent array. You can get this, and then if you do not apply, I'm just going to rub this. Yeah, so if you do not do path compression, if you do the normal find operation, so when you are looking for parent of 4, you will look in this parent array, you will see that parent of 4 is 5, but 4 is not parent of itself, so find does not terminate here. You go to 5 is parent of 5, terminates, so and then it will return to you that parent of 4 is 5. If you look for parent of 3, then if you want to find the parent of 3, then you will first find that it is 4, then you will go to 4, you will find 5, then you go to 5 is parent of 5, so actually the parent of 3 is 5, so then your find operation will do this whole recursion and then return you 5. Now what we are saying that instead of doing this every time, because that is a costly operation, if we are doing it for 1, then we know that on the way when we are going from 1 to 5, all of these elements which are coming on the way, 2, 3 and 4, also have the same parent as 1, which is 5. So why not just update that value while we are computing for 1? Okay, so when we compute for 1, 1's parent is 2, 2's parent 3, 3's parent 4, 4's parent 5, and then 5 is returned to 4. So then 4 is going to update its parent, which is actually 5 only, Then 4 returns 5 to 3. So 3 will update its parent to 5. Then it returns to 2. 2 will also update its parent to 5. And then when it returns to 1, 1 is also going to update its parent to 1. So after this this like tree like structure that are formed, which it will look like this. So now if you need to find parent of anyone, there is only one lookup. Earlier there was order n lookups could have been needed in worst case. I mean, not order n, like here you would have used many more lookups, and here you would need only so amortized. I mean, when you do this path compression, then amortized, you are going to reduce the cost of find operation from worst case order n to order log n. So that's the idea. So I hope that is clear. And I hope the problem is clear, and why the disjoint, how we are going to solve this with disjoint set union data structure. If we do not use disjoint set data structure, then we can brute forcely, we'll solve this in about order n square, which is like, sorry, I mean order q into n, which is order n square roughly, I can say. And but if we do use disjoint set data structure, then we can solve in order n log n time. So that is so I hope it's not clear. Okay. Okay, if it is okay, great. Yeah, it was a little confusing. The problem statement was a little confusing with the IDs, but it's not a tough problem. It's a simple problem only. And okay, so we do not have time to discuss more. I will share the code with you. I mean, tomorrow I have also not posted the code for the last week, so tomorrow I'm going to do it for both the weeks, last and this week. And I will also post the recording of the video, and yeah, I will then send a notification to everyone on Discord. So if you have any questions, then I'm here. If not, then we can end the session. Yeah, you can unmute yourself.
Ma'am, actually, I had some doubt on last week assignment problem, ma'am.
Okay,
Small clarification, ma'am.
sure.
Ma'am,